So I want you to imagine that this left screen is a driver's mobile phone, and this right one is a restaurant view. So if we just log in here as test1, and we log in as also a restaurant owner, or just someone managing the restaurant. Now, as a driver, let's say we're starting a journey and we have a current location, which is, it uses your device location. Currently I have mine disabled, but we have a default one just for show. And a destination. Let's say we just want to go to Helsinki. And we have some journey preferences here. Current battery, current range. These we would like if they would come from directly from our vehicle, but here they are. And then desired charge at stops. This we can modulate as well. Let's say it's 80 because that's a nice round number and it means our battery is going to stay healthy for longer. Choose a connector. We use CCS and Italian and American. That sounds good. If we're going to charge, then let's eat well, right? But before we do a search, let's view also our settings. Here we have these more persistent ones. So your EV model, connector type, and then generally what your desired charge is, as well as your food preferences. But yes, your EV model, it's going to affect how our AI system will predict the charge time and so on at stations. But yeah, so let's go ahead. Let's run. Now, as you can see, we have 5 charging stations suggestions. Starting from Mukkulankatu, we have a charging station with a CCS charger up to 2000 or 200 kilowatt, and a couple restaurants here. Now that looks nice. I'm feeling hungry already, so let's go for one that's like right at the start of our journey. Let's just choose that one there. Have some BBQ ribs, delicious. Onion rings, two helpings. How about some iced tea? Check out. Right, that's a lot of good stuff. Charging coverage, charge, €50 in the same bill. So you don't have to have 2 payments. That sounds great. Place order. Awesome. Now what does it look like on the side of the restaurant? Let's imagine that this was already open in this specific restaurant. Now, briefly, we saw a pending item here, but it quickly moved over to cooking. Now, why did this happen? We chose a restaurant that's really close. Now, the problem with this is that the restaurant hasn't had time to actually start cooking, but maybe for the purpose of this demo, it's good that we saw how it moves over to the cooking column when the restaurant should start cooking the meal. Because based on these values here, we have like the longest cooking time, which is 15 minutes. This system, it's going to basically tell the restaurant when to start cooking. Now, if the time is, it's like 12, it's 18 past 8. It's like, yeah, we should have started cooking this in the past already. But anyway, this isn't a very a good example. But hey, we can see that it moves over automatically when into the cooking column when they should start cooking. Now let's say this driver, has now driven to the station and they pull up to the charger, and let's imagine that they put the charging plug into their car, which is what start charging is kind of emulating. Now their car has started charging. They can walk inside, and once the restaurant has finished the meal, they can mark it as ready, and once the person picks it up, it will shift into the picked up column. Now, at this point, the restaurant will be able to monitor the charge of the vehicle. This is also going to help the restaurant basically monitor what their customers, the status of their customers' vehicles, which is kind of going to allow them to get a better operational view of their restaurant. They can see what's going on in the users' cars. Anyway, right? Let's choose another example. Let's say we're going to Helsinki again, but maybe for maybe instead we'll choose one that's later. So we have like Lahti, Kerava, right? And then like Helsinki. Let's choose maybe like Kerava, maybe opera. How about some lasagna, garlic bread, maybe not red wine because we're driving. Check out, great, pay. Now, if we have a look at what it looks like on the restaurant side, here we have an order, and it's much later. It's staying in the pending column this time because the start cooking it's in like a little less than an hour. But yeah, so now if we imagine that this driver in a perfect world, they would stay on time, and they would arrive in 57 minutes exactly, and the restaurant would essentially have the meal ready exactly 15 minutes, or they would start cooking 15 minutes before they arrive, and it would be ready when they arrive. They have a lovely hot meal as soon as you arrive. But let's say that using these special developer controls here, just to mock the situation, let's say that the driver is 7 minutes late. So basically their ETA is showing 7 minutes after their reservation time. So the way the system works is that when you make an order, it's going to say, this is when it thinks you're going to arrive. So it's going to start a reservation 10 minutes before that time. But if you arrive, let's say, or the ETA is going to be 7 minutes after the original, pressing this button basically mocks what the system would be doing automatically all the time, right? So checking the ETA. But we hit that button and it just said that the reservation was pushed forwards because it knows that you're arriving a little bit late. Now, as we also noticed that the start cooking time is now also later than it was. So in real time, it's going to be checking what the ETA of the driver is, and it's going to try to push the reservation forwards constantly. And also this means that the restaurant it's not going to cook food just to end up having it sit on a counter because it's the person isn't arriving on time, and then at that point no one's happy. But yeah, works pretty nicely if it keeps updating. But yeah, and those are the main features of our application here. So thanks for watching.